Episode 58, titled Identify Malicious Code, TTPs, and Host Artifacts, we treat host analysis as rapid pattern recognition backed by verifiable artifacts you can pull on demand. The goal is to see behaviors first, then confirm them with traces that stand up to peer review and postmortems. We will name the common families of malicious code, tie them to the tactics, techniques, and procedures they favor, and show where solid evidence appears on real endpoints. Think of this as training your eye to notice recurring shapes in process trees, file systems, memory, and telemetry, then proving those shapes with hashes, logs, and captures so containment is decisive rather than tentative.
Persistence patterns are the drumbeat you can learn to hear across platforms, and they are gratifyingly verifiable. On Windows hosts, scheduled tasks, run and run once keys, service installs, and Windows Management Instrumentation (WMI) event consumers create durable footholds. On Unix and Linux, cron entries, systemd units, and profile script edits play the same role. Quick validation steps include enumerating autoruns, listing recent task creations, diffing service definitions, and querying WMI subscriptions with timestamps and creators. Strong programs keep known good snapshots for these locations and alert on deviations, which turns a sprawling search into a short comparison with a receipt of change. Persistence is rarely subtle forever. It prefers places administrators also use, so it leaves artifacts in familiar drawers. Credential access techniques leave crisp artifacts if you instrument the right places. Local Security Authority, LSA, dumps involve suspicious handle access to LSASS, unexpected mini-dumps in temp paths, and kernel callbacks that protection drivers will log when enabled. Browser store targeting appears as access to login databases, cryptographic API calls in unusual processes, and rapid reads of profile directories. Keylogging produces low-level hooks, driver loads, or steady file writes that match pressed key cadence. Immediate containment triggers are simple and firm. Terminate the offending process tree, isolate the host from sensitive network zones, force credential resets for identities present on the machine, and snapshot volatile evidence before memory rotates. These moves cut off reuse while preserving the story you will need to tell. Discovery and lateral movement read like reconnaissance, evolving into action, and segmentation signals help you decide how loud to ring the bell. Discovery uses net commands, ARP and ipconfig, registry reads of run keys, and queries for domain membership or shared folders. Lateral movement then pivots to remote procedure call, RPC, server message block, SMB, and remote desktop protocol, RDP, from unusual sources. Watch for administrative tools running in user contexts, service creations on peer hosts, and authentication events without interactive logons that imply token or hash replay. Tie these events to your network design. When attempts cross forbidden boundaries, your firewalls and microsegmentation should also light up, giving you independent corroboration that a host is probing past its lane. Collection and staging are the quiet middle chapters before data leaves, and they reward patient file system and handle inspection. Look for temporary archives in odd places, unusual compression utilities dropped next to business files, and hidden directories with innocuous names that hold disproportionate volume. Stagers often walk directory trees in alphabetical order, skip already encrypted formats, and create lists of target paths before compressing to a single working file. Reliable signals include spikes in file open handles, creation of .zip or .7z archives in user temp paths, and anti-forensic attempts to set attributes that hide or system flag staging folders. When you see these, you are minutes to hours from an exfiltration attempt. Treat them as a pre-alarm rather than a curiosity. Exfiltration channels tend to be simple and popular, but their timing and entropy make them stand out against baseline. Hypertext Transfer Protocol Secure (HTTPS) beacons that carry data do so in steady intervals with payload sizes that differ from casual browsing. Domain name system (DNS) tunneling encodes data in labels, yielding long, high-entropy queries to a small set of newly observed domains. Cloud drive abuse uploads blocks in rapid succession to consumer endpoints that your policy may not bless. You do not need decryption to notice these shapes. You need destination reputation, size and timing analysis, and clear allow lists for sanctioned services. When outbound precision is high, deviations are loud, and you can interdict without taking down legitimate work. Host artifacts are your proof kit,
and collecting them systematically reduces guesswork. Process trees tell lineage and intent. Hashes anchor files to intelligence. Loaded module lists expose injection and hollowing. Network connections correlate with flow data. Prefetch entries on Windows reveal execution history and frequency, and event logs record who did what and when. When possible, enrich these with command lines, current working directories, token information, and parent image signatures. A small set of artifacts, gathered consistently in the same order, lets different responders reach the same conclusion without arguing hunches. The pattern is simple. Tell a short story, then point to the artifacts that make it undeniable. Endpoint detection and response, or EDR, telemetry, Yara rules, and known good baselines are your confidence multipliers when humans are tired and time is short. EDR gives you process lineage, command line capture, file and registry touches, and user context in one place. Yara describes byte and string patterns for families you care about and can be applied to memory or disk. Known good baselines let you say that a module list, service set, or autorun profile deviates from a stable norm. Use these together: baseline to highlight drift, EDR to narrate the drift as actions, and Yara to label the family when signatures exist. This stack lifts detection from looks weird to matches behavior X with these corroborating signals, which is what containment decisions deserve. Adversaries try to spoil your trail, but most anti-forensic behaviors are themselves detectable. Timestamp stomping creates clusters of identical creation or modification times that do not match user activity. Log clearing leaves gap patterns and event ID sequences that jump. Alternate data streams, ADS, on NTFS hide payloads behind innocent names, yet still reveal themselves in stream-aware listings. Mitigation approaches include forwarding logs off-host in near real-time, protecting critical logs from tampering, monitoring for suspicious use of time-setting utilities, and scanning for non-resident streams on directories where they do not belong. Even when evidence is thinned, residue remains if you know which corners to sweep first. A short scenario shows the analysis rhythm from suspicion to action. An analyst notices a new parentless PowerShell.exe spawning 7z.exe with a long command line reading user profiles and building an archive in a temp folder. Process lineage from EDR shows the parent was spawned by a signed tool, runwl32.exe, with an unusual working directory under a user-writable path, and network telemetry shows periodic HTTPS posts to an unapproved domain. The responder kills the process tree, isolates the host from sensitive subnets, preserves volatile data, and collects hashes and prefetch entries for the involved binaries. A Yara scan tags the loader family, registry checks reveal a new scheduled task, and a quick credential review flags an administrator token present during execution. Credentials are reset, the scheduled task is removed, the archive is quarantined, and the egress rule is tightened to block the destination while similar patterns are hunted fleet-wide. We will close with two concrete, durable moves that turn today's material into muscle memory. First, build a host artifact checklist that names exactly what to collect on Windows, Linux, and macOS, process tree, hashes, modules, sockets, autoruns, prefetch where applicable, key event logs, and a minimal memory capture when allowed, along with the commands or tools your team will use and the order of operations. Second, stand up a lab replay using safe samples, simulators, or red team scripts that exercise the behaviors you care about. Persistence via scheduled tasks, process hollowing queues, small HTTPS beacons, and DNS label staging, so analysts can practice pulling artifacts and confirming conclusions. When those two assets exist and are used routinely, host analysis stops being a scavenger hunt and becomes a reliable, teachable craft. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.